Hello everyone. Welcome to another Teach Kelvin Your Thing session. In this session, I'll be having Nico Jansen teach me mutation testing with Striker.js. So if you don't know what mutation testing is or what Striker.js is, you're in the right place. So let's meet Nico. How you doing, Nico?
Hi, I'm fine.
I'm really glad to have you on this session. So could you introduce yourself, tell us who you are, what you've been working on, and why you are teaching us mutation testing with StrykerJS today?
Sure. I started my career, I think, 15 years ago. I started just as a developer. Later on, I discovered this thing called mutation testing, which was just a niche back in the day for mostly Java projects. So we started using that. It was called PyTest. It's a framework for mutation testing. But we thought, well, wouldn't it be awesome if it works for JavaScript as well? So that's yeah. We decided let's try it. Let's try to make it happen, and that's how we started Striker as an open source framework. Um, so yeah, it's also a tool to help you write good tests. So I hope that I can get that across today as well. Um, so yeah, I'm really
Yeah,
excited.
cool. Nice. Thanks for that intro. So I think we can start on the note because obviously I don't know what mutation testing is. So
Mhm.
let's start from the why. From like why do we need mutation testing? And yeah, let's start from that note and build up onto
Yeah,
Striker.js. Yeah.
yeah. So the question is not why you need mutation testing, but why do you need testing in general?
Mm,
Because
okay.
it's mutation testing only makes sense when you have tests. So,
Okay.
but yeah, so if you're writing unit tests, for example, or integration tests, it's difficult to know what when the tests are good enough, right? So, how would you know that the tests are good, are doing actual work? Probably you have good tests if they can catch bugs.
Mm-hmm.
So that's what mutation testing is about. So it's a way to automatically insert bugs into your program to make sure that your tests are catching the bugs.
Oh, I see. So if I get you right, you only need mutation testing if you have tests in your applications, right? And
Yeah,
with um with mutation testing, you could insert bugs and make sure that your tests are catching those bugs.
yeah.
Right? Yeah,
So
okay,
it's not a
cool.
new way of testing. It's a way of measuring the quality of your tests.
Okay, cool,
Yeah,
cool. That sounds interesting. So how do
yeah.
we
It's
get
best
started
best
doing this?
yeah, yeah.
Yeah.
It's best explained with an example.
Mm-hmm.
So
Yeah.
let me show you what. Um, yeah. So um, this is the example application that we're using for mutation testing. Let's first show you what the application is about. So
Mm-hmm.
it's the future, right? So in the future, you go order your drinks at a bar, but of course there's a robot there serving the drinks.
Mm-hmm.
And this is the application that you have on the tablets in front of the robot.
Okay.
So you can order some drinks. So you can you can order a Coke, for example. Let's order two. You can submit the order. Um, here's the confirmation page. If you confirm, then you get two colas now.
Mm-hmm.
But it's a low budget bar, so for now it's only this application. But normally now comes a robot inside this room and brings me the drinks.
Nice.
That's how it works.
Okay.
Um, there's a little bit more to this because if you order a drink with alcohol in it, I have to say how old I am. And if I'm, for example, 8 years old, I'm not allowed to buy this drink.
Mm-hmm.
But if I'm 36, then I am allowed to buy this drink.
Nice.
So that's the application.
Okay.
Um, well, let's take a look at the source code for this one.
Mm-hmm.
Um, it's using native web components. You might have heard of it from
Yeah.
your last episode with Elliot, an awesome
Yeah.
episode about lit.
Yeah.
Um, everyone go watch that if you didn't do that yet.
Mm-hmm.
But this is actually not even using lit. It's just using native web components.
Okay.
Um, for example, we have the place order component. And here's the connected callback that you might remember. And here, because I'm not using lit, I have to do the actual work of cloning the template myself and appending it to this to my own to my own component. And the template is inside different directory, different file. But it's like this. So I've got HTML here as templates, just native template tags. So these are the things that lit would abstract away for you. But I chose this example without a framework in mind. So you can just doesn't really matter what kind of experience you have, because it's just native JavaScript and native web components.
Yeah.
So this is the first page. So to work here, so we first get the drinks from the server, and the drinks are inside this nice JSON file somewhere here. I think it's here. So drinks.json.
Okay.
And there is alcoholic if it's an alcoholic drink. And whenever we get them from the server, when we render the page, and we also do the click handlers and all these things. So that's how it works. And now, so for example, here's the table to add the drinks here. Here. And I've got the class here, and this class is being selected here as well. And we just replace the children with the list of orders. So that's how it works. So just native HTML.
Oh.
So right now I don't have any tests for this. But what I did do was I added no tests are here, but I added Jest already here. So Jest is a test runner for JavaScript.
Okay.
The most popular one at the moment, I think. Have you ever used it?
Yeah, I've used it at some point, but I had to move away from it for personal preferences. But it's good.
So you like another one better?
Yeah. So I mostly test right now. I'm using Japa. It's a Node.js testing. Framework. Yeah.
Ava, yes, okay. It's also a famous one, yeah.
Yeah.
Cool. So I've configured it, but I haven't written any tests yet. So let's look at testing as next.
Okay.
So if you go do research about what kind of tests there are, then you usually get these kind of graphics. Have you ever seen it? The testing pyramid?
No, I haven't really, but I do know what these concepts are in terms of testing. Yeah.
Indeed. So the idea is that on the bottom of the pyramid, so it's a solid base of the pyramid, you have the unit tests, and it's really wide because the pyramid gets wider if you go down. So you need a lot of them to make a solid base of the pyramid. Otherwise, the pyramid would fall down. And also, the further you go down, the faster the tests are to run as well. So unit tests are generally really fast, really cheap as well, because you can just run them whenever. It's really easy to integrate them, for example, in your CI/CD pipeline. And on the top, you have the UI tests, and those are actually the opposite. So the tests that actually need a browser and a user clicking through the browser, or a browser automation. So these tests are pretty expensive to run. So generally, you want to have a solid base of unit tests, and in the middle you have integration tests. So you might think of them as, for example, you integrate with the browser, or you integrate with the database, something outside of the scope of your pure code, or you want to integrate different parts of your application. You want to test the integration. If you compare it to Legos, you can think of it a unit test as a test that just tests the color of a Lego brick, or just to see that the space between the spuds are actually 3.5 millimeters, for example. These kind of tests. Integration tests are when you put two blocks together. You want to test that they stick together properly and that you can pull them apart
Mm-hmm.
if you apply force. And then UI tests might be that you build something, a house maybe, and you want to test that you can reach every room inside that house or something else, something like that.
Nice.
So these are the ways to think about it. Now if you look at our application, there's actually some places to start. I think is really to get the concept across. It's easiest to start here. So whenever there's an amount, so it's a European robobar, so we have euros. Whenever there's an amount on the screen, we use this function to put it on the screen.
Okay.
So a unit test can just focus on this one line of code in this case, just one function. So let's start with that. So let's create a test file for it. So currency. I use the same name as the thing that I'm testing, but with test in the name.
Okay.
Currency pipe test, and here I've got the scribe concurrency. Oh, currency, sorry,
Okay. Currency. Yeah.
like that.
Yeah.
And in here, so this is a test suite for currency, and in here I got, for example, it should prefix with a euro sign, like that. Oh, let's start with this. Just leave it empty for now, just to make sure that my tests are actually running. I go and start run jest. So let me open a new terminal here. Yeah. So npm test. Oh, and you can see that it's already finding my test correctly. So that's working. It's running it, but it's empty, so it's always passing.
Yeah.
So let's call the currency pipe. Automatic import here. Just need a postfix with .js because I'm using ECMAScript modules. So then with ECMAScript modules, the extension is required.
Yeah.
For example, if I call this function, now I would expect a result to contain, for example, the euro sign. Oh, I don't have it on my keyboard, so I'm just going to copy it here from here.
Okay. That's good.
This is a test, for example. If I now run the test, yes. So you can see that it's working. Succeeding. It's always good to test what happens if they are not succeeding. So let's just replace this here. So this is a way to test your tests as well. So make sure that it's able to fail. So it is able to fail. So this is a good test.
Okay.
And what you might see here as well, I'm always printing the coverage here. So this is, do you know what code coverage is?
Yeah, I do.
So so here there's 100. You know what that means?
Yeah, it means the pipe.js, the file has 100% coverage, like the functions or the inputs have.
So if I were like a developer that's just starting out with writing tests,
Mm-hmm.
and you see this 100, you think, well, this is nice. I can proceed with the next thing on my to-do list. But
Okay.
what do you think about this test yourself?
Well, I think we're only testing the happy path, like what happens when you do find a pound, but we don't test other things that could happen if there's no pound, or maybe we're not even giving it like an amount even.
Yeah,
Yeah.
and not even testing that amount, right?
Yeah.
Yeah. So there, yeah. So even um, yeah. So for us, it's actually not well tested at all. Well, code coverage won't ever tell you that. Code coverage is just it's happy already.
Yeah, exactly.
I can make it even more extreme. If I can just forget about this, right?
Mm-hmm.
You can forget an assertion. If I now run it again, then of course it's also 100% because I didn't change any code paths. So
Wow.
it's even worse than that.
Mm-hmm.
Um, but let's proceed. I want to do another one. So let's do this drink summary pipe. The drink summary pipe, you give it a couple of drinks, and it will say how many there are. So let's start with that as well. So this is another file, so it's another unit. So I
Mm-hmm.
need another unit test file for that. That's best practice.
Yeah.
Oh, got drinks
Yeah.
summary.
Um, I'm kind of curious at the dot pipe insertion on these
Yeah,
files. Is it like a convention for you, or I don't understand?
yeah. It's actually the name that an Angular application would give to these kind of things. These are just basically
Okay.
functions pure functions that you can call, and it will just um, it give you back a string to be placed on the screen. You can think of
Okay.
it that way.
Okay.
Yeah.
Cool.
So, so yeah, yeah, I could have called it factory method or something as well, or
Okay.
but basically just pure functions.
All right. Got it.
Um, so there's a reduce here, and there's like this thing here. So let's just um, describe it here. Drinks summary. It should provide summary for no drinks. Always good to start with no drinks. Drinks summary. Uh, let's give it provide it with an empty array to start. And I expect results to be 0 drinks. Nice.
Okay.
Let's run the tests. There is actually something wrong here. It's passing, so that's nice.
Mm-hmm.
But there is something wrong with code coverage here. So code coverage is actually spotting that there are still missing paths here. So let's look at the code coverage report. Just also prints. I've configured it to also print this or to output this file. So let's open it with. I've got a plugin here called Live Server, and what it will do is it will automatically it will open this report in a browser and automatically reload whenever the file gets edited.
Nice.
So let's open it in a different tab here. That. Oh, I was hoping it was. Let's see. But but so it should be in this port. Yeah, I put it. Yeah, and you need to open the correct file, of course.
Okay.
So let's just copy and paste it. This
Yeah.
this is the code coverage file.
Okay.
It's pretty nice. It has these UI elements, so progress bar and percentages and these kind of things. So if I go to the navigate to the pipe, first the currency pipe, it is 100% coverage, so every line is covered. And then the drink summary pipe, and here you can see with red that there is stuff that is not covered. So apparently this isn't covered, and this isn't covered.
Hmm.
Do you know what we can do about that?
I don't think I do. And for some reason, I think some part of your screen is being cut off.
Sorry.
Yeah.
Um,
So
oh,
even
let me. Is this better? Yeah.
yeah, it's better. And even your editor, like
Yeah.
the file
You
explorer is
cannot see
cut
the
off.
files, but
Yeah.
that's fine.
Okay,
It's
it's
not a big
fine.
problem.
Okay, cool. Yeah, so let's see. Number of drawings. Do we need to test the reduce method?
Yeah, I'll just try to improve this part a bit.
Okay.
Indeed. Do you know what how we can do that?
Hmm. Just I don't I think we might need to pass in the arguments. That's the
Yeah.
drink summary expects.
Yeah. So it's an right now it's an empty array,
Yeah.
uh, which means that this reduce function is never executed, or
Yeah.
at least the function inside of the reduce. So the
Mm,
callback that I supply here, this is
yeah.
actually never executed.
Mm,
So total will just be a zero because that's the default value being passed in here. We'll
yeah.
just put it here, and so it will be zero. So there will be an S at the end as well. So it will be zero drinks.
Mm-hmm.
Um, yeah. So let's improve that. Um, Start with it should provide one drink summary, or should support a one drink summary. Let's call it like that. Now I'm calling it with one drink. So drink summary. Here I need to provide order items. I've got a nice helper for that. Create order item. And here I can just provide an amount. So let's say it's one. For example, one robo beer.
Okay.
And now I'm expecting the result to be one drink as a string, like that. And again, now I've got 100% code coverage.
Nice.
And if I look at the report, it even updated. So again, if I'm like a developer that's just starting out with testing, I might think I'm done. I already did two files, 100%.
Mm-hmm.
Um, but yeah, again, I think as a developer with some experience, you might see some code paths that need a little bit more testing.
Yeah.
Because I'm only testing one amount now and zero amounts, but not more than that.
Mm-hmm.
So there are still stuff that needs to happen here. So let's see what Striker will do. So Striker is a mutation testing framework. So let's install and run that and see what mutation testing will do with these two examples.
Okay.
Um, there's an README of this. I'll share it as later. This is the link to this repository. But there's a nice install guide as well. But you can also maybe you should start with actually showing the website. If you go to StrykerMutator.io, then you can see our documentation here, just in the browser. You can see that Striker has actually three flavors because we also support C# and Scala.
Mm-hmm.
Basically, um, any project within our company, we want to be able to run mutation testing on those. So
Oh,
we got some projects in C#, we got some projects in Scala, and in JavaScript. And we also have projects in Java, but also Java has already a mutation testing framework, so we can just
okay.
use that. We don't need to build our own.
Okay.
So if we go to JavaScript, there's a nice introduction here, um, and also getting started, um, which allows you, which explains what you can do. Um, so I want to install directly, so I can just copy this here and just paste it here. While that's installing, I can already go to the next. So I can init Striker with this init command, big Striker init. And now I'm getting some questions here. I hope this is visible.
Yeah.
The first question is, do you use one of these frameworks? So if you're using one of these three frameworks, we get automatically configured stuff for you, but we don't because we're just using native web components, no framework. Then it asks which test runner are you using? So you mentioned Ava. Ava is actually not supported out of the box by Striker. But in that case, you can just use the command test runner. It's a bit more slow, but it does work.
Okay.
But for now, because we're using Jest, I can select Jest here. Now, which reporter do you want? I want all of these, so just like this. And which package manager do you use? I'm using npm. And then the last question is, which configuration file do you want, JSON or JavaScript? And I choose JSON. And what's going to do now is it installs the Jest runner plugin in Striker, and it configures Striker with this JSON file here. So this is what I get out of the box. There's one addition that I need to do here, unfortunately. It's because I'm using Jest with native ECMAScript modules. There's still work to be done here. That's also explained here.
Okay.
I need this. This just means that I'm running Jest with experimental VM modules, which is a requirement for Jest to support ECMAScript modules.
All right.
Yeah, and I'm using a different configuration file by default, so that's why I'm configuring it here. So next up, we can run Striker with npx striker run. And it comes with the same kind of format that we just saw with code coverage. But you see some different numbers here, right?
Yeah.
So the currency pipe is only 66%, while the string summary pipe is only 90%. So mutation testing will spot a lot more stuff that you forgot to test.
Yeah, I could see some queued 11 to 9. Yeah. I don't know what that is at this point, so I'm just gonna wait till you get to it.
Just the higher the better. So if it's 100, then it's fine, but it's not. It's lower.
Okay.
So let's open this in the browser as well. So I got the code coverage report here, and then let me just open this one. Same. So our UI is a bit richer because we have dark mode and light mode.
Oh.
It's the first thing I always show.
Yeah. Cool.
And let's I can make it a little bit bigger, I think. You see different, so you got something called killed, survived, timed out. We'll look at those later. Let's just focus on pipes first and the currency pipe. So here there's actually a survived mutant. So apparently I forgot to test something here. You can see it with the red squiggly. And if you click here, you can actually see what Striker did here. So Striker actually says, well, I could just remove this question mark here without a test failing. So that's interesting. There's also 2 killed mutants. Maybe look at those as well. So this actually means that Striker could try to change this, but a test failed. You can even see which test failed. It's here in the details. So currency should prefix with a euro sign. That test failed. So that's nice. And this is the other one. If you empty out this string, it's also causing a test to fail. To make sure that this actually doesn't fail anymore, I need to actually test the amount, right, that I provide, and also test with an empty amount.
Yeah.
So let's get back to the to our editor, and let's see if we can add those. So apparently there's also the possibility of an undefined being passed in, and then what should happen then? Oh, this is drinks, right? Oh, that's something else. Should go to the other one. So undefined. What should happen now? I'm actually curious. Probably you want something like 0 or something, but the way it's written now, I
Yeah.
probably wouldn't do that. So let's make it to B as well. Um, let's run the unit tests. B. So what it was actually outputting was undefined. That's probably something you don't want to see in your UI.
Yeah, I think I've seen those kind of stuff in UIs when you see
Yeah,
null or undefined. So I think this kind of test should catch
exactly,
that.
exactly.
Yeah.
So this is something that Striker will see because it's mutating the code and see that there's not a test that's passing, or sorry, that's failing.
Mm-hmm.
So probably you're missing some use case.
Yeah.
Um, so let's actually fix this. I can do that, for example, using this to have a default value here,
Okay.
or maybe something like NA, not that's available, something like that. Say that a product owner says that he or she wants to see this.
Okay.
Okay, so that's the first one, and let's have a look at the other one. The drink summary. It's the reduce here. That's actually the same kind of issue. So let's forget about this. I was hoping that it actually was also complaining about this here, but apparently it's not. Um, could have written it a little bit differently, but let's first run Striker again and see if this is improved. Yeah, so now there are 5 tests even failing. So this is actually also something that Striker will find and make a replacement for, a mutant for.
Okay.
And it's also failing, so that's nice. And so you see that question mark. It's the nullish coalescing operator.
Mm-hmm.
It will just tries to be smart about it and replace it with a logical AND operator. Which means that we're actually testing that the first path is nullish, so either null or undefined. Because if it's not, then this will make sure that the right hand side will not be executed because it's a logical end.
Yeah.
So yeah, that's the basics. So if you now if you reach 100% mutation score, then you are a lot more sure about the effectiveness of your tests. Because Striker will do all these kind of mutations to your code, to your production code, and we'll test that your tests are actually working. Questions so far?
No. So the thing I don't think I understand is the columns where we have
Yeah.
killed, survived, and what mutants are in the context of Striker. Yeah.
Yeah. So let's go through them. So we have killed. Killed means that's good, right? You don't want mutants to live. You want mutants to be killed. So that's what's happening here. So everything that's green here, that's actually good. Then you also have survived. Survived is that a mutant survived. So a mutant was created, but there's no test killing it.
Okay.
These are actually the main ones.
Mm-hmm.
We've also got a third one that's timed out. You can imagine that if Striker mutates your code, that it will end up with an infinite loop, for example. So we can't say if it's killed, we can't say if it survived because it takes too long to run, and in the end, Striker will just give up. And in that case, it will be a timeout for that mutant.
Okay.
There's also no coverage. That's basically the same as survived. But since there is no coverage for that test or for that mutant, we don't even run the unit tests because it's no point, right? If you don't cover a mutant, then yeah, does it really matter?
Yeah.
So if you go back to the start, there are actually a lot of mutants with no coverage. For example, the components, these are all not covered. So you can see that there were 122 tests or mutants created, but none of them were killed or even covered.
No. Okay, cool. So is there a rule that governs how we are making these mutants out, or what this like
That's a good
what
question.
yeah, like
Yeah,
yeah, so just
let's
the
go.
rules
Yeah,
behind
let's,
the mutants.
so let's go back to I've got some slides here. So this is what mutation does, testing does. It will insert a mutant into your source code, and that mutant will either be killed or survived, or timed out, or something else, and then it will report it. So this is an example. Oh, this is something's wrong here with the zoom level, but
Mm-hmm.
um, can you see it? Yeah, a
Yeah,
little bit.
yeah, yeah.
Let's just go to the website. It's probably better to look here because we got supported mutators page, which have actually everything that we mutate is documented here. So these are the arithmetic operators. So plus becomes a minus, minus becomes a plus. So we are actually trying to find the opposite operators.
Okay.
Um, because yeah, for example, and let's look at the equality operators here. These are the equality operators that we mutate. For example, double is sign, double equal sign will be mutated to not equal. We could probably mutate a double equal to a triple equal as well, because there is a difference between the two.
Mm-hmm.
But that might be, yeah, it might be stretching it a little bit. But yeah, there are definitely there are infinite ways you can mutate the code, of course.
Okay.
So we try to find a good set that everybody agrees these are actually really valuable. These are also pretty interesting, I think. So we have less than, we mutate that to less than equal. So we try to see if you actually tested the edge cases. Because if you don't test an edge case, then of course, yeah, you probably want to test the edge cases. That's actually
Yeah.
mutation test or unit testing best practice.
Okay. That makes sense though.
Um, we also test mutation test regular expressions. So if you know regular expressions, you know you can do a lot of crazy things there.
Mm-hmm.
And we basically also do that. So this is contributed by some students. It's an awesome project. It's called Web and Regex, and it's a way to mutate your regular expressions. So it will actually Striker will actually parse your regular expressions, and it will mutate those as well,
Okay.
so smartly. So for example, this um, yeah, it's what's it called again? A greedy operator or something like that. So the ampersand, it's being mutated to not an ampersand.
Okay.
It's about multiplicity, right? So
Mm-hmm.
um, what I think is interesting about regular expressions is that the code coverage of a test that's hitting a regular expression is always 100%.
Really?
Because inside of the regular expression, there is no code coverage, right? So
Mm-hmm.
if you have a regular expression that is one line wide, it will always be 100% covered as long as you have one test. So
That's
mutation testing is actually the only way to look inside of the regular expression. Um, there's also string literals that we also mutate. Um, maybe another one that's interesting is the method expression. So ends with is being mutated to starts with. So if you have an ends with in your code, you probably are interested in that it's a string actually ends with that, right?
yeah.
That's why you use ends with. So
Okay.
if you can mutate it with starts with and there's no tests failing, yeah, probably you're missing a test there. So these are actually also really valuable.
Interesting. Okay, so from your explanation on this, on the way we get the mutations. So in Striker, once a mutant is applied, the test is supposed to fail the
Exactly.
mutants and it shouldn't pass. So by failing, it actually passes because it's actually catching the other
Yeah,
side of the
exactly.
spectrum.
Yeah,
Okay. All right. I
you
think I
need
get
to.
it.
Um, yeah, so let's. I actually already did this work, so I already wrote all the tests. So I'm
Okay.
removing the tests that I created now, and I'm adding all of those,
Okay.
um, just to show you what it looks like in the end.
Yeah, that it's actually does make a lot of sense. So like in the basic case, if 2 plus 2 equals 4, 2 minus 2 should not equal 4.
Exactly.
Yeah.
So, but you think, well, this makes a lot of sense. Why would you need mutation testing anyway, right? If you just write good tests, you don't need it.
Mm-hmm.
Well, it's actually pretty difficult to write good tests.
Yeah.
Um, I changed the cursor, so let me just put it back the way it was.
Okay.
And run the test again. You see that I've got 100% here now. So I've got
Mm-hmm.
tests for everything. But when I run Striker, it'll take a little bit longer as well now because there are more mutants to test.
Okay. So
Or
it's
there's more tests found, sorry. So
okay.
um,
And it's just generating those mutants and testing the tests.
yeah,
Testing the tests. That sounds nice.
testing the test, exactly.
Yeah.
So this is only not even 60%. So 100% code covered, but only 60% or less even is tested.
Hmm.
Let's look at the report here. Because there's an important component. It's the review order component because that one has the check for the alcohol.
Mm-hmm.
Um, you can also see that there's a lot of strings that are not tested. So the entire routing is actually not tested in this application, even though I've got 100% code coverage.
Mm-hmm.
Um, but let's see the age check here. Here, see this one is allowed to buy alcohol check. If the age is larger than 18, it's allowed. But there's one case that's surviving. That's the greater than equals. Let's zoom into that. So this is the review order components. Let's go to the code. The review order components. This one. Um, so I've got two tests here. Is allowed for a user that's 24 and is not allowed for a user that's 12. So I forgot the edge case.
Yeah.
So let's write that now. So I just copy this one now, just to speed up the process.
Yeah.
So the edge case is for 18. So make the age 18, and it should be allowed to buy alcohol. So this is the test. So let's run it. You can see there's one failing test now. Do you know
Yeah.
why?
Yeah,
Have you seen it?
because the you said greater than 18 in
Yeah.
the logic. Yeah.
So I'm not sure how it is where you live, but where I live, you are allowed to buy alcohol if you're 18.
Yeah.
Uh, so this is actually a bug in my application.
Yes.
So with mutation testing, it's also possible to find bugs
Yeah, like
um,
it just
because
show you the yeah, cool.
you forced yourself to really test everything, and then when you're writing the code, you actually think, well, this should actually be like this,
Yeah.
and you should not be allowed when you're 19. So maybe I need that test as well. Um, so let's actually add a test here as well, but for a user that's 19. Sorry, that's 17. Yeah,
Mm-hmm.
17. And should be an error. So this is the test for that. Let's run unit testing. So just to reiterate, the coverage didn't change, right? It's still 100%, but Striker will actually will help us now. And I'm going to pass incremental now as well. I'll explain this flag in a little bit, but for now, the first time you run with incremental, it just does the same thing as before. As you can see, it takes some time to run mutation testing, even on a small application like this. And let's look at the code. And now you can see that this actually is killed. Every mutant here is killed. So if you look at these mutants, so less than is killed, greater than, true and false. So Striker will also try to just replace everything here with true or false. I would say it's good that we killed those.
Yep.
There's also actually a runtime error here. Maybe it's good to look at that as well. So that's another of the states that you can have. Let's see where it is. It's here. So apparently, if you call custom elements.define without specifying the name of a component, that's not allowed. You get a runtime error if you do that. So that's actually what Striker will, of course, not know exactly where it can mutate. It will just try everything. And runtime errors, they will just be reported as runtime errors. So Striker will do its best to know the difference. So it's not killed, it's not survived, it's actually an error. And error mutants are just left out completely from the calculation.
Okay.
Like I said before, mutation testing takes a long time. This is why we created incremental mode. If you pass incremental to Striker, you can either do that with the flag or with just adding it here. So if you there's also IntelliSense in the configuration files. So if you add incremental and you pass through here and you run Striker, then it will try to reuse as much as it can from a previous run. And as you can see now, it's just directly done because I didn't change anything to my code.
Yeah.
For example, if I would now make a change here, then Striker would rerun. So maybe I can add a test. So look at the report, see if we can add a test. For example, this only adults can buy alcohol. This error message is actually pretty simple to test. Yet in practice, you see a lot of users not doing that. So let's go to the preview order component once more. Instead of expecting this error not to be undefined, I can just say expect it to equal, and then the error message. Because I'm lazy, I'm just going to copy the error message. Only adults. That's this one. I just changed one test now.
Okay.
And if you run Striker with incremental, it will see that I only changed that part, and it will surgically only test those mutants that are in scope, and it will update the report. So that's why it's pretty fast. It's just 6 seconds now. And you can see that this one is now also killed.
Nice.
So the biggest reasons for people, I think, not to use mutation testing is probably because they don't know about it. But if you know about it and you choose not to, it's probably because of performance reasons. Because if you have a large project, mutation testing scales almost exponentially. You can do some smart things, as Striker also does. For example, only run tests that cover a mutant for a particular mutant. But then still, it can take a long time, and that's why we implemented this incremental mode. So it doesn't really matter how big your project is. as long as you run with incremental mode, it only runs the changes. So if you do small changes, it'll just be fast every time.
Nice.
Um, so questions or
No, I think so at a high level, I really understand the importance of Striker and mutation testing. It's just, I'm thinking because, testing is that thing you should do, but you don't. Yeah. So now I'm thinking it's hard enough to get developers to write tests. How going to get
yeah.
them to write mutation tests for their tests?
Well, you don't really write mutation tests, right? You
Mm-hmm.
write tests. So as long as
Okay.
you have tests, you can use mutation testing. Um, the way I think about it is usually
Mm-hmm.
is when you want to use code coverage, you should actually think about not using code coverage, but instead just move to mutation testing.
Yeah, yes, yes, yes,
Um,
exactly. So that was a speaking from me. So you don't write mutation test, but you use it as a tool to check your test if you're catching
yeah,
all the logic you think you should be catching, which makes a lot of
yeah.
sense. Yeah.
Generally, I think if you write unit tests, you probably care about the code quality and about the quality of your unit tests.
Okay.
So I would probably always use mutation testing, to be quite
Oh,
honest.
okay.
There are reasons not to write tests. For example, if you're writing throwaway code or code for a presentation or for a demo, yeah, then you don't write tests. But
Mm-hmm.
if you write production code, you probably want to write tests because of the testing pyramid as well.
Yeah.
You want to have a solid base because if you don't know that the units work, how do you know that your application as a whole will work?
Mm-hmm. Yeah.
Um, so in that case, probably you want to use mutation testing. Um, and I hope Striker will help you a lot with getting started. This configuration file is difficult maybe to start with, but um, yeah, we have a lot of documentation on our website. Every configuration option is documented, and I hope you yeah.
Yeah. Thank you. Yeah. Thanks a lot. I think I'm definitely going to use it. So I have a question.
Mhm.
We just talked about um unit testing. So currently, I'm trying to do more of E2E tests with Playwright. Can
Yes.
I use um mutation testing for those sort of scenarios?
Well, so if you look at the testing pyramid, you probably want to, if you're using Playwright for your end-to-end tests, you
Mm-hmm.
also want to have unit tests to make sure the units work.
Okay.
Otherwise, you probably will spend a lot of time if your project grows, you'll spend a
Mm-hmm.
lot of time waiting on end-to-end tests to finish if you want to
Okay.
test everything.
Cool.
So that's why we don't focus on Playwright at the moment. That being said, there are reasons that you want to use Playwright for unit tests.
Mm-hmm.
So it might make sense for us to start supporting that as well, but it's
Okay.
not supported out of the box. So instead of having a test runner Playwright, you should probably use the command test runner here.
Okay.
Um,
Oh, right.
and
Cool.
then um,
Okay.
Striker will now um, just use your test command, so npm test, to run
Okay.
your tests.
Okay, so yeah, that makes sense because the testing framework I use, because in my project salescast.com I have two sort of tests. I have unit testing with Japa, not Ava. So Japa
Yeah.
is kind of new, but I
Mhm.
think I like it because it's mostly focused on Node.js applications.
Mhm.
So if I'm going to use Japa with Striker, is there a way for me to ignore the playwright test and just run the unit tests since both of them are in
Yeah.
the same applications?
So you would do like this. You will configure the command test runner with a
Mm-hmm.
command npm run Japa, you said?
Yeah, Japa. JAPA.
So
Yeah.
I think you can know this one exists. And
Yeah,
then
it's
in your package you can have a script for Japa.
okay.
Then you just run Japa here. For example, if it's Japa run, then you run it
Mm-hmm.
here.
Cool.
This will just be running that script, right? So just
Yeah.
be running this command. And um, if the command exits with a zero exit code, then the mutant survived. If it exits with something else, then the mutant was killed. Every test runner supports that philosophy, right? So
Yeah.
if tests fail, then the process fails. It's always that. So
Okay.
that's so it will work. Just the performance will be a little bit worse. For small projects, it's probably fine, but for bigger projects, we might need to think about supporting Java natively
Okay.
with that plugin. Because if you, for Striker, for example, the Jest plugin is pretty smart about which tests to run for which mutants and all these
Yeah,
things.
that's true. Right. So I'm definitely gonna. I think I would set up Jopper with
Yeah,
Striker to
try it with
just
this. Yeah,
have a feel of how it works. Yeah, sure. So thank you.
cool.
So if
Nice there.
if I want to reach you about Striker, or is there anything you want to plug?
Yeah,
Yeah.
sure. So we have the website.
Hmm.
Let's show you it once more. So it's strikermutator.io.
Okay.
There's also a blog here where we, for example, this incremental mode is explained in this blog article.
Mm-hmm.
So whenever we have a large release, we try to write a blog article about it. If you go to the bottom here, there's also our Twitter plugged here. So it's twitter.com/strikermutator. Um, so whenever we have something to say, we'll tweet about that.
Okay.
And there's also this Slack. So we're on Slack. So if you want to reach out,
Okay.
have questions, want to discuss test quality, new mutator ideas, something like that, you can just join our Slack as well.
Okay. So where can we reach you if I want to ask you a
Yeah,
question? Yeah.
my Twitter, yeah. So I'm on NicoJS underscore NicoJS. It's my Twitter. So feel free to give me a follow and reach out that way.
Okay. Thank you so much, Nico. Thank you a lot for this session.
Okay, cool. I hope you liked it.
Yeah, I did a lot, and I'm going to use it in my tests as well.
Nice. Okay. Well, thanks for having me, and see you.